Hello students, in our previous video we have learnt about the potential difference and defined it as the change in potential energy of a charge moved from one point to another divided by the charge, which is also known as voltage. Students, you know potential difference or voltage can also be defined in terms of work done. Don't get confused here. It is the same thing but viewed from a different angle. How? Let us understand it. We have seen earlier that it was the battery which was giving energy to electrons to flow from low potential to high potential once they have traveled in the circuit. In physics, whenever we transfer energy, we say we are doing work. Just like battery does on charge. Here work is done to move the charges as battery is giving energy to electrons to move against the electric force. Note students, electric force is always in direction from high potential to low potential. Once electrons travel in the circuit in this direction, they come to low potential. From here, they have to be moved to high potential, again for them to flow in the circuit. This push against the electric force is given by battery and hence it is called work done on charges by battery. For example, if we take a 3-volt battery, there is 3 joule of work done on 1 coulomb charge as battery is giving 3 joule of energy to 1 coulomb charge. Remember students that unit of energy and work is same, that is joule. But they are not same. Work is the outcome or result of mechanical energy transfer. But since they are related to the energy, both of them have same units, that is joules. Now let us understand potential difference in terms of work done in detail. As you know, the point at which unit charge has less potential energy is called lower potential. In a similar way, the point at which unit charge has more potential energy is called higher potential. The electric potential difference between these 2 points is called potential difference or voltage. Now consider 2 different points A and B in an electric field of a charge Q. Electric field is nothing but area around charge where it exerts its electric force on other charge. Here the area and the direction of force is indicated by arrows. Here point A is much closer to the charge Q than point B. Electric force decreases from point A to B. Now, say another unit charge that is 1 coulomb is placed at point B. This unit charge has electric potential energy VB, which is less than its potential energy VA at point A. In order to move the unit charge from point B to point A, work must be done on the unit charge against the electric force of charge Q. Also, there will be repulsion between them due to same charge. If work is done on unit charge, energy gets transferred to the charge and it will start moving from point B to point A. Hence, at point A, the unit positive charge gains more electric potential energy. The electric potential of the unit charge at point A is VA. The amount of electric potential energy gained by unit positive charge on moving from point B to point A is called as potential difference. Therefore, the potential difference between 2 points is VA minus VB. The difference in electric potential energy of a unit charge between 2 points within an electric field is called electric potential difference. It is also defined as the amount of work done to move a unit positive charge from a point of lower potential to a point of higher potential against the static electric field. So electric potential difference can be mathematically written as VA minus VB is equal to work upon charge. Accordingly, if 1 joule of work is done to move 1 coulomb of charge from one point of lower potential to the other point of higher potential, the potential difference between these 2 points is 1 volt. In a similar way, if 5 joules of work is done to move 1 coulomb of charge from a point of lower potential to a point of higher potential, the potential difference between these 2 points is 5 volt. Now students, try this by yourself. Calculate the work done in moving a charge of 2 coulombs across 2 points having a potential difference of 14 volts. Students, this is the method of calculating potential difference theoretically, but how to measure it practically? This is done by an electric equipment named voltmeter. It is used to measure the potential difference between 2 points in an electric circuit practically. When the voltmeter is connected to the circuit, it shows the voltage, which is the measure of potential difference or the difference in electric potential energy between the 2 terminals. Voltmeters are of 2 types. One has needle and is called as analog voltmeter, and the other looks like a digital clock and called as digital voltmeter. So students, we have learned the potential difference or voltage in terms of work done and how to measure voltage in a circuit. Now students, every time when we want to represent the flow of current, we cannot draw all the elements. So we will represent them in the form of symbols. How to do this we will see in our next video.